So what is chip load? Well, you can see from the calculation here that chip load equals feed rate divided by RPM times cutting edges. Now, if you want to be, really accurate, increase your knowledge of CNC operations and all that, then you can remember that calculation. But most of the times, what I do is I just go out on the internet and find either a little cheap calculator or a document that has a description of what are best feeds and speeds. I use those as a good start um, so that whenever I start off with something, I'm within the acceptable range of good cutting practice. This may seem a little bit backwards to ask what is chip load as a calculation and then come to part two. But if I went through part two first, you'd forget everything for part one. So first of all, we talk about what is chip load, and then secondly, we talk about why do we care. Okay. So what chip loading does is controls the required settings for cutting the work material. Okay. So when we have differing types of material, we need to have different rotational rates for the router bit, different feed rates for the router bit through the material. So the reason we do that is that we get a better finish for the material and we keep our bits alive longer. So when we properly calculate the chip load, we control the amount of heat that is the worst enemy possible to our router bits. Okay. So ironically speaking, running slower with a higher RPM or even a slower RPM is not necessarily going to keep our router bit cooler. On the other end, running high speed with high rates of travel through the material may also produce extra heat. So what we're looking to do is give us the best cutting with the best rotational rate so that we don't overheat our bits. Okay. And you can see that I've got up here, it affects tool wear, it affects the material removal rate. Obviously, if we have a good removal rate, we're moving at the fastest possible speed, and that gives us the minimum amount of time spent cutting the material. And we all know time is money. And finally, we can see that it affects the material surface finish. So if we're doing something like, let's say, cutting a 3D piece, if we're just removing the parts around the 3D portion of the cut itself, and then the rest of it we use, let's say, a big hogging or rough cut bit, then this allows us to use the right bit for the right cut and also at the right speed and feed, and that allows us to reduce the amount of time that we're on the machine. So it helps us to turn parts faster. When you go out on the internet, you'll find, as I mentioned earlier, I believe, a lot of different formats for finding recommended feeds and speeds. The simplest ones are the charts, okay? And this is a ShopBot document, but it will work with just about any kind of CNC because we're going to, it's really talking independently of the machine. We're talking about the bit type, chip loading, how many flutes. It even goes into the brand and inches per minute, and you can always convert that to metric if you need to. So you can see that they have it for different materials: hardwood, medium density fiberboard, soft plywood, laminated chipboard, laminated plywood. So this is not a bad place to come check, just if you want to take a look at some rough recommendations. You can see here that the chip load per leading edge is 0.004 to 0.006. That's for a 60-degree carbide V cutter. So the RPM setting on that is 18,000. That's a fairly high RPM setting, but it's a soft plywood. And the feed rate is 2.4 to 3.6 inches per second. Okay. So I bet that if I were to come up here to the hardwood, let's just go straight to the hardwood, and we look at the same bit, okay, And now we can see the 18,000 RPM, and the feed rate is 2.4 to 3.6 inches per second, and the chip load is 0.004. Now, this one is obviously a lot harder, so you're going to be a lot more careful whenever you cut this material. Now, let's get away from the PDF document here and use something that is a little bit more user-friendly, perhaps. This is not a bad site, guhdo.com, and they have some nice, simple calculator here. It's not the most detailed calculator, but gives you some recommendations. So let's see that I was going to use a 1/4 inch cut through on MDF material for a countertop, let's say. So what it's going to recommend is it's going to give me the diameter, it's going to give me the wood type, okay? It's a hardwood, there's the softwood, MDF, soft plastic, hard plastic, okay? So let's say that we're going to cut medium density fiberboard, and so we're going to use a 1/4 inch bit. So the recommended chip loading is 13/100ths of an inch to 16/100ths of an inch, or 16/100ths. So if we come over here and we look at the feed rate, okay, let's set the feed rate at about 18,000. Let's go ahead and go with what the previous website had. And let's just set the inches per minute feed rate. And the number of flutes is 2. And you can see we're at 0.004. So we are at a 1/8 inch setting rather than the 1/4 inch setting. So we can do several things here. We can either bump up the feed rate, okay, and we can see that we're going up to 0.007. If we went all the way up to 300, we're going to be still not within the max chip loading. Okay, so let's turn down the speed a little bit, and we're still not quite there. So what we're seeing here is that, typically speaking, we probably are not using the optimal speeds for our machining process. Now, forgive me, I don't typically push the machines this aggressively, but you may. And this is a pretty nice place to come for just some basic starter points. So let's come over here to the speeds and feeds calculator here. And this asks a little bit more questions. You got your RPM, okay, the number of flutes, 2. It gives you some options: softwood and plywood, solid surface, and then to select the tool diameter. Okay, so let's say that we're going to set it. Let's see if we're consistent with what the other site said. And so we'll set it at 16,000 RPM. We have 2 flutes, softwood and plywood, and the tool diameter is 1/4 of an inch. And so we calculate, and what we see here is that we can run up to 352 inches per minute, okay, for a maximum of 416 inches per minute for the range of the chip loading on that. So this is obviously something that I would still work up to. I wouldn't start at 352. I'd probably start a little slower, a little lower on that, to see what kind of cut I'm getting from the material. You see, it's not simply an issue of following by rote what it is that the calculator is providing you. It's also a matter of judgment in there. Okay, so let's see. There's the ShopBot site, and there are obviously a lot of videos out that talk about all the aspects of using chip load calculations, and that some of them are from the manufacturers themselves. So it's never bad to go out and pick up some information there. Now, if you want to get really finicky, you can come to the website. Let's see. Oh, GWizard. Okay. This one's fairly involved. It gives you 30 days worth of free trial, so you can experiment with it. It asks you to set up your speeds, okay? Set up your machine, then set up the materials, set up the feeds and the speeds. It's very involved, but then whenever it gets done, conceivably speaking, you could have the optimal to the nth degree uh, recommendation for your feeds and speeds. So, if you want to spend a little bit of money, you can. I think that this was $29, so it would be a downloadable application. I also noticed that there were some applications for chip load calculating on mobile devices. So that's also another option if you want something to carry around with you in the shop. is 4 different speeds for 3 different bits. Okay, this is a pointed roundover bit starting at 12,000, 14,000, 16,000, and 18,000 RPM. This is a 90-degree V-bit starting at 12,000, 14, 16, and 18. And this is what's called, sometimes referred to as a core box bit or a roundover bit, and 12,000, 14, 16, and 18. Now, if I were to judge just overall by glancing at the quality of the cut, core box bit with poplar did exceptionally well. I didn't have to clean anything up out of this. It came out very nicely. The problem is it's a fairly big cut, so I don't know if it would behave the same way with a smaller core box bit. It could be, you know, that something like a 1/4 inch might not behave so well. But, you know, that's one of those things you just got to experiment with. The second in quality is the V-bit. And the problem with the V-bit is every single one of these has got a little bit of roughness down in the bottom. Let's just call it doo-doo. Okay? And but the best one is the fastest, 18,000 RPM. The slow one actually did pretty well too, but for some reason the 14 and the 16,000 RPM, the 16,000 is just really coarse and rough. Okay, the last one is a pointed roundover bit, and this one, no matter what the speed, it just looks horrible. I cleaned this up with a toothbrush just to try and get the rough, the almost leftover sawdust that I thought out of it, but it wasn't leftover. It's just wood's being treated very poorly. So, what's the lesson learned? Well, first, the bit that you use has an impact on the quality of the cut. These bits were all exactly the same used exactly the same amount, which is hardly at all, so they were as sharp as they were when they came from the manufacturer. And they were all cutting the same material. Okay, so the feed rates were all the same. The only distinction was differing RPMs. The lesson we learned here is if we're going to use a V-bit, need to use a little faster and be prepared for a little bit of cleanup. But this would clean up quite well. Okay, I don't think there'd be any problems with this. A little sandpaper, no big deal. None of these would be cuts that I would want to have on something that I were going to try and give somebody or sell. It's just not that high quality. And then of course the core boxes, man, that is just so smooth and clean. That is, you know, almost no sanding whatsoever. So that's the lesson for today, and I guess it's a lesson for you whenever you get out there and you start to cut wood. You want to make sure that you've got the settings right for your feeds and speeds. Otherwise, you're going to wind up wasting a lot of material. And you know, the old saying in woodworking still applies when you're doing CNC work, and that is you want to measure twice, you want to cut once. So practice on one piece, and that until you become familiar with that material, and then, then use your second cut to deliver the customer's piece. And that's pretty much it for today. Have a good one.